Hey guys, and welcome to the solution video for the Hamming distance problem. We had quite a few responses to this one, which is really good, and we've had some really good code submitted, so that's fantastic. Let's just quickly go through the problem first. We'll go through these solutions, and then we'll kind of break it down to show how it's done. Let me zoom in just a touch. So basically what happens is you're given two integers, so suppose you're given 100 and 254. These look like this in binary, so we can see, let's go a bit further. There we go. So there's your 100, there's your 254. And if you look down, so if I start with this bit here, notice how these are different. So wherever these bits are different, we basically put that as a 1. So we have 1 that's different here. Let's say there's 1. These are the same, different here. So in total we've got 1, 2, 3, 4 positions that are different. And that's basically what a ham distance is. We're basically going through the binary digits of a number and saying for each position, if the bits are different, add it up and basically go through to the end. So suppose you had 254 and 254 like this. There we go. Let's move that forward a second. Let's put a little hashtag here. This would have a ham distance of 0 because for each kind of position, they're all the same. So that'll be a hamming distance of 0 here. Whereas this one is 4 because there are 4 positions where we have differing bits. Our first submission, I really hope I pronounced this correctly, is from Chudoria Cobb 8874. So thank you so much. This is great. This is really nice, clean code, and I really like this. You've got a nice use of a for loop here. So let's go through it from the top. I'm going to quickly call your function. So we expect 4 to be returned here. Yeah, we get 4. That all looks good. So let's see what you've done. You first use the bin function to basically take A and B. I think you've done the 2 colon here because, just want to double check I'm correct on this, it does like an OB before it like this. So if I run that real quick, yeah, OB. So I take it you've done this bit here to basically kind of cancel out this and just focus on these bits here, which looks good. And you've taken the max len and then use zfill. So I take it this is to kind of handle situations where if the numbers are vastly different sizes, you can fill the leading one to zeros, and that's really cool. Yeah, I like that. That's a good idea. And then this bit here, it looks like you've maintained count as equal to 0, and you've gone through them together. So you're going through A and B, they're binary strings, and saying for each position, if the bits are different or if they're not the same, go to count, increment by 1, return the count. Yeah, that's cool. I like that. It's a nice, simple, straightforward, neat way of achieving that. So again, thanks very much. That's really nice. Next up, I think it's Ortman. I hope I pronounced that correctly. This is the video I butcher everyone's names, so if I do, I apologise. Okay, we've got a few interesting bits here. Let's see. So we have a list and reversed. Okay. And then we have that same kind of 2 thing as well. I don't know if we need to reverse them or not, but that's fine. It looks like it works. Let's go ahead and call your code. Let's see. Hopefully we get 4. Looks good. Very nice. Okay, so we're creating our lists first, iterate over. Oh, this is quite cool. So yeah, so you're basically doing a bit of logic here to make sure that the lists are the same length. If they're not, okay. Yeah, so you're extending the shorter one. So you basically say the lengths are different, extend the appropriate list to now make sure that it's the same length. Nice. So you're zipping together both the lists and then doing a pairwise comparison. Nice. So in a sense, like this bit here is similar to this bit of the previous solution. So yeah, pretty nice. I like that. That's good. Next up, we have Ross K. Graham. I'm going to quickly call your code first, but this looks good. Very functional. 4. Nice. Okay. So let's see what you've done. A bits and B bits here. I'm going to just quickly print off one of these guys. Let's do A bits. Nice. Okay, so this, let's have a look. Okay, so you're converting to an int for each B in the binary string of A, and then, okay, so I presume, let's just for a second kick this guy out. Okay, that's why you've done that, so that would fail without this. So let's just remove this for a second. Sorry for this code butchery. Okay, cool, yeah, so I can see why you've done that now. So you've done a list comprehension to put this all out like this, converting to an int, yeah, that looks good, and then you've then done this bit here to make sure that we aren't going to actually include this bit in the string. Yeah, cool. I think that's really nice. Very functional. I like this kind of style of doing a comprehension to get the answer. That's nice. And then we see zip longest, which is quite cool as well. So zip longest, just in case you didn't know what that does, suppose you have ABC, and then suppose you then try to zip that with another string like DEF, G, I don't know, something like that. The zipped thing would be like AD, BE, CF, and it would cut off the G here. Whereas with zip longest, you pass in this fill value, and then if one is shorter than the other, it just fills the shortest one with some fill value, in this case 0. So that looks good. And let's see what you've done here. B for B and zip longest, but only do it if they are different, and then return the len for that. Nice. I particularly like this one. Very functional, very clean, and gets the job done. So yeah, thanks very much. Next up, we have probably the shortest one. So this is by Keith Kazama Flick. Once again, I'm awfully sorry if I've not pronounced that correctly. And this one looks like it's using a bitwise operation. I'll make it a bit bigger. It's a little bit smaller. Now, let's see. We have XOR. Okay, yeah, so this is using the exclusive OR operation here. Now, you can use this in a few contexts. You can use it for sets as well to do a symmetric difference, I believe. So you've done the XOR var, which is A bitwise B, using the XOR. Converted that to binary, and then done a count of 1. That's really neat. Yeah, I think this is really cool. You can make this even shorter, actually. If you were to do, let's see, just make sure it works. Yeah, you could even just stick this in here and make that a little fancy one-liner. Look at that. That works, cool. Now, this is the one that I would have kind of gravitated towards, because this is inherently like a binary operation or using bits. This is the one that I would have kind of gone for myself, which is quite cool. So I want to kind of do a rough breakdown and show kind of how you would arrive at this solution. But yeah, this is fantastic. I really like this. So I'll comment out for a second, just to show you kind of how this is working. So suppose you had 5 in binary, so you have 0, 1, 0, 1. Suppose you had 3 in binary, 0, 0, 1, 1. A bitwise XOR operation like this basically does kind of what we're asking at the very start of the question. It goes through the bits, and we only get a 1 for each place if the bits are different. So we have 0 here. That's because 0 and 0 are the same. We have a 1 here. Zoom in a second. We have a 1 here because 1 and 0 are different. The 1 is here. Again, the same thing. 0, 1, they're different. And a 0 here because these are the same. So what you then get is you then get this back at the end. But this actual A and B operation here doesn't return you the binary straight away. It just gives you the number. So if I show you what that looks like, if I just did print AB, we get 12 back. So then what you do is then you do, kind of build up kind of gradually. If you do bin of AB, this, there we go, should get OB1100, yeah. And then simply doing count of 1 here, we're basically saying how many times does 1 appear, and we get 2. So guys, thank you so much for submitting all of your code. It's nice to see all of the different styles and all the different ways of solving this really nice LeetCode problem. I'll be releasing the next question probably around the middle of August, so make sure you keep your eyes peeled on the community tab. But that's it guys. Again, thank you so much. Hope you all have a great weekend, and I'll see you all in the next video.